So we are essentially just continuing on with something that we have worked on last class, and that's finding exact solutions. This time we're opening up with the tangent problem, and you have to remember that the period of tangent is different than the period for sine and cosine. The period for sine and cosine is 2 pi. The period for tangent is what? What? It's not 2 pi, what is it? What is the period for tangent functions? Ideas? Pi. Every pi tangent repeats. Okay, so every pi tangent repeats. We keep in mind that the period for tangent is pi. We're going to be doing the exact same thing we did before. Now, if we have anything on the outside of our trigonometric functions, we're going to want to get it to the other side. In this case, I have a plus radical 3, so you're going to have to subtract radical 3 on both sides so that you get your tangent. So tangent of theta is equal to negative radical 3. All right? And then, of course, you think, where on my coordinate plane, on my unit circle specifically, is my tangent equal to a negative 3? What quadrants? So just to go back here and make it absolutely clear, you're looking for negative tangent values. And for all students take calc, which I taught you, in the first quadrant, all of your values for your trig functions are positive. Your second, only your sine is positive. Your third, only your tangent's positive, and your fourth quadrant, only cosine is positive. So that means that in the second and in the fourth quadrant, you have negative tangent values, okay? So we have to think of those radian values that produce negative square root of 3 initially in our 0 to 2 pi interval. So what are our two values? Tangent of what radian value gives me negative square root of 3? 3 is equal to radical 3 over 3. Your tangent, oh sorry, pi over 6. Your tangent of pi over 4 is equal to 1, and your tangent of pi over 3 is equal to radical 3. So based on those reference angles, you know that the two answers have to have a 3 on the denominator. So based on that, what are your two angles from your interval 0 to 2 pi that are going to produce a negative radical 3? What's one of them? Well, you want 0 to 2 pi. Which would be what in radians? Well, we're talking about quadrant 2 and quadrant 4 specifically. 2 pi over 3, right? 2 pi over 3. Because pi over 3 is just positive radical 3. So you need a 2 pi over 3. Because this is specifically in quadrant 2. And in quadrant 2, that's where you have those negative tangent values. What's the angle in quadrant 4 that has negative tangent values? Yeah, 5 pi over 3. Now, because your interval is 0 to 4 pi, you keep adding pi, right? So every time you add pi, you get a coterminal angle. Remember, coterminal angles start and end in the same place. So you want to keep adding pi or subtracting pi until you get all of the coterminal angles within your specific domain. In this case, if I add pi to 5 pi over 3, get 8 pi over 3. And then if you add 8 pi over 3 to another pi, you will get 11 pi over 3. Can you go any further with that? Can you add another pi and be within your domain? No, no. And if I added a pi to 2 pi over 3, I just end up with 5 pi over 3, so it doesn't really, I don't have to add a pi. You don't want to subtract because, again, you'll be outside of your domain since you're from 0 to 4 pi. So you have 4 answers in this interval. 2 pi over 3, oh, let's not do that kind of green. So you've got 2 pi over 3, 5 pi over 3, 8 pi over 3, 11 pi over 3. Do we have any questions about how you are expected to complete these problems? No. The big thing to remember is the period. The period for cosine and sine is the same. It repeats. The cycle repeats every 2 pi. The period for tangent is different. The cycle repeats every pi. So keep that in mind. Now, example number 2 is more challenging because even though we are more used to sine and cosine graphs at this point, we've had more practice with them, you've got several things going on. You've got a square root of 2 in front of the cosine, you've got a plus 1 on the outside, and you've got a minus 3 pi over 4 on the inside. So you have a lot of transformations taking place. You have horizontal shifts, vertical shifts, and stretches. But if you remember what we did last time to solve these types of problems, you're going to be doing the exact same thing. So let's take a look here. Typically, when you have a problem that you need to solve, again, you want to make sure everything around cosine is moved to the other side. So we're going to do that. We're going to go ahead and subtract 1 and then divide by radical 2. So that you end up with that. Well, we know we don't want a radical in the denominator, so you're going to get rid of the radical in the denominator. You end up with this. Now, because we have a translation, we're going to have to change our domain to fit that translation. Because we're not dealing with just x. As I said last class, now we're dealing with x minus 3 pi over 4. So you want to go ahead and change your domain. So let's go ahead and change our domain. So instead of 0, it's less than x is less than 6 pi. 0 minus 3 pi divided by 4 is less than x minus 3 pi divided by 4 is less than 6 pi minus 3 pi divided by 4. go ahead and simplify that new domain. So let's go ahead and simplify that new domain. You have negative 3 pi over 4 is less than x minus 3 pi divided by 4 is less than 21 pi over 4. All right. So now you're going to be thinking of all the places where you have the cosine of a radian value being equal to negative root 2 divided by 2 that fit this new domain in pink. All right. So go ahead and think of that. And those are going to be the values for x minus 3 pi over 4, not just for x yet. So we're not there quite yet. So just think of all those values, list them, and then we'll finish by simplifying. So I'll give you time to do that now. All right, so when you do this initially, you're just thinking of all of the places where you have a cosine of a radian degree that gives you negative square root of 2 over 2. The first thing I thought of was not actually this negative 3 pi over 4, it was a positive 3 pi over 4 and 5 pi over 4. Those are the values that are in your second quadrant and your third quadrant, right? You keep adding 2 pi, and you go until you can't go anymore. Well, you get 11 pi over 4, 13 pi over 4, 19 pi over 4, and 21 pi over 4. Obviously, given your new interval, you can't go past 21 pi over 4. Now, the reason that you have a negative 3 pi over 4, looking at your new interval, it goes from negative 3 pi over 4 to 21 pi over 4. Oh, wait a minute. Yeah. Okay. So that's just looking at our interval there. Now, because we have a minus 3 pi over 4, these aren't actually our answers, right? And it doesn't make sense with what we have right now. So with our current domain. So to get the correct answers, we have to add 3 pi over 4 to every single answer in purple, okay? So it both fits our domain and gets rid of that translation and just gives us what x is actually equal to. All right, so to get our final answer, we're going to be adding 3 pi over 4 to everything. And so you finally get x is equal to 0, 3 pi over 2, 2 pi, 7 pi over 2, 4 pi, 11 pi over 2, and 6 pi. And actually looking at this again, I think there's a mistake in your textbook because it's not less than or equal to, so I don't think you're going to include these values. Okay, I'm going to start this one. So just to make it clear on this recording, the book had a less than or equal to sign, less than or equal to x, less than or equal to 6 pi, which is why they included those extreme values 0 and 6 pi. But because mine did not have that in the original notes, you're going to have to take those out, and that makes sense. Now, Emily asked about the transformation, and I do want to have this on the recording just so that you can go back and understand here. Your original domain, 0 to 6 pi, is for x, excluding any transformations. As soon as you add a translation, you are naturally moving your graph left or right, which is going to affect your x values. Therefore, you're going to have to show when you're looking for possible answers for x, how it's going to affect your domain in order to find the correct answers. So I had to subtract 3 pi over 4 initially from my original domain, because that's actually what's happening to all my x's. They're being shifted to the right, 3 pi over 4 units. Once I found all of the possible x values from negative 3 pi over 4 to 21 pi over 4, you have that for x minus 3 pi over 4, but of course we want just for x. So you have to add 3 pi over 4 to all of those answers, and your results are the possible intersections between the cosine on the left side and y equals 0 on the right side, from 0 to 6 pi. All right? Okay. The next one is pretty challenging because you've got two domain changes here. You've got a 2 in front of your x, and you've got a minus pi over 3. So the very first thing that you want to do is apply the 2 to your domain. And the next thing that you want to do is apply that minus pi over 3 to your domain. Then you want to simplify and look for possible values within that interval. So this becomes negative 7 pi over 3 is less than 2x minus pi over 3 is less than 5 pi over 3. So you're looking for all the possible values where tangent is equal to 1, and that is in between the domain negative 7 pi over 3 to 5 pi over 3. So give that a try. If you're having trouble where to start, you will always make that coordinate plane. Look at all students take calc. I see that I have positive tangent values in quadrant 1 and in quadrant 3. And those two values where I have a tangent of 1 is at pi over 4 and 5 pi over 4. At this point, you ask yourself, okay, am I going to add pi or subtract pi in order to get the rest of the values within the domain in black? If we add pi, we're going to exceed our domain, which ends at 5 pi over 3. But if I subtract pi, I'll stay within the domain. So you're going to start subtracting pi until you get to a point where you cannot exceed negative 7 pi over 3. And you end up with two more answers. And that's negative 7 pi over 4 and negative 3 pi over 4. Does anyone have any questions about those two additional answers and how to get them? So we're not quite done because we have to get rid of this, right? So we have 2x minus pi over 3 is equal to pi over 4 and 5 pi over 4 and negative 7 pi over 4 and negative 3 pi over 4. Just like solving any equation, you're going to get rid of everything to get the x by itself. So you want to go ahead and add pi over 3 to all of your answers and then divide all of those answers by 2. So when you add pi over 3 to all of your answers, you now have 2x, which is going to be equal to negative 17 pi over 12. Negative 5 pi over 12. 7 pi over 12. And 19 pi over 12. You're going to lastly divide everything by 2 to get x by itself. And you get x is equal to negative 17 pi over 24. Negative 5 pi over 24. 7 pi over 24. And 19 pi over 24. That is your final answer. So the process is all the same, just remembering the different periods and remembering that if you have a transformation, you have to apply that at the end. It's not a difficult process, it's just a long one. Sometimes. Do we have questions? Because I'd like to answer them on video if I can. Or any points that need clarification. Okay. Let's move on to the next page here. They were all sine, cosines, and tangents equaling specific numbers within an interval, right? But never really the combination of both a sine and a cosine. If problems required you to go back to the original values on your unit circle from 0 to 2 pi, and then you either added 2 pi or subtracted 2 pi or added pi or subtracted pi. But you have to know where on the unit circle that you're looking first. That's always where you start. Okay. All right. Now, we've got finding these exact solutions between 0 and 360. This one actually isn't that hard. The next two aren't that bad. So go ahead and try those on your own. They gave you to degrees this time rather than radians, so that's kind of nice. Mm-hmm. Yes. Now the thing is, you want to keep in mind that if you see a sine and a cosine, usually you're going to want to get a tangent out of it. And we know that the ratio for tangent is really just sine over cosine, right? Because on the other problems, if you think about them, look here, you don't have that. You have a sine theta and a cosine theta and a random square root of 3 in front of it, right? So we have a difficult case, or not a difficult case, but a different case here. So my initial thought when I see sine and cosine is, should I get tangent? And the answer is yeah, because you want to get it equal to a particular number, right? So if you divide everything by cosine, which you can do, you end up canceling some things out here. First of all, sine over cosine is tangent. And you have a 1. Now we have it set equal to a number. And we just have to get rid of that square root of 3 in front of the tangent. And this interval is super easy because it's from 0 to 360, 0 to 2 pi. There are 2 places where tangent of theta is equal to radical 3 over 3. What are those 2 radian values? Marco, which ones?
Pi over 6 and 7.
Yeah, pi over 6. And 7 pi over 6. those are the two places where you've got tangent value being square root of 3 over 3. So if you take the tangent of pi over 6, you get square root of 3 over 3. If you take the tangent of 7 pi over 6, you get square root of 3 over 3. Questions? It boils down to, do you know your unit circle? Okay, because if you don't know your unit circle, you really can't start anywhere. All of these. Now, there are going to be cases where you've got something that is squared. And those are nice because they remind us of those quadratic functions that we know how to factor and we know how to graph. There'll be parabolas, things like that. Like before, because we've done this in the past, you have taken something, you've used substitution, you've factored it, and you've resubstituted and got your final answer. So that's how we're going to approach these problems. Instead of saying 2 sine squared theta plus 2 sine theta plus 1 equals 0, just treat it like a regular quadratic equation. And factor that. If it's non-factorable, then of course that means that you're not going to have a solution, right? And I always suggest that when you're looking at a factoring problem, always check for your discriminant first. That's the whole point of discriminant, right? It's going to tell us how many solutions we have. So looking at this, I check for my discriminant. My discriminant is b squared minus 4ac. Well, b squared is going to be 4 minus 4 times a times c. What's the problem there? Do you remember? Yeah, there's no real solutions. This can't be factored. There's no solutions between 0 and 2 pi. And if you graph that in your graphing calculator and look at that interval, you'll see that it doesn't intersect, right? And so you're not going to have a solution. It doesn't intersect the x-axis, which is where y is equal to 0. So, no real solutions. Questions? The next one, you can treat, again, sine x as x, because you're going to be using substitution here, so just make x equal to sine x. And then start factoring, so we're really looking at 2x squared plus x is equal to 0. We can factor that. You can take out an x. So you have x is equal to 0 and 2x plus 1 is equal to 0, so x is equal to negative 1/2. You substitute back in for x your sine because of this up here. So you go back in and you say, okay, well now sine x is going to be equal to 0, or sine x is going to be equal to negative 1/2. So again, you think of all the places where sine is either equal to 0 or where it's equal to negative 1/2. Find all the possible radian measures within 0 to 2 pi. So let's go back up here and think about our solutions. You should have gotten 1, 2, 3, 4, 5 solutions. What are they? What's one of them? Someone tell me. You're looking for x values here. Well, where's your sine 0? Between 0 and 2 pi. 0 and 2 pi, right? So those are two answers. You have 0, you have 2 pi. Where else? What about negative 1/2? In radians. 7 pi over 6. Yeah. What else? 11 pi over 6. Is there any other place where your sign is 0? We have 0 up there. What about pi? Pi also, right? Questions? X equals 0 or, well, are you talking about here? It's one, the other, or both?
Like, I got either sine x equals 0 or sine x equals
2 what?
1.
1. Well, did you set, you said this equal to 0, right?
Oh, it's because I saw the question wrong.
Oh, okay, that's,
Because I wrote down 2x squared plus 2x.
okay, that's okay. That's literally what I did for the last question with the domain. That's okay, it happens. But does the process make sense? All right. Yeah.
Why is pi negative?
Because if you look on your unit circle, you have 0 and 2 pi. You've got pi over 2. You've got pi, and you've got 3 pi over 2. Right here, you've got the point -1, 0. So your cosine is -1 there, and your sine is 0 there. So that's another place where your sine is 0. Does that make sense? Okay. Last. Okay, so this last one, we're gonna go ahead and again substitute. Instead of sine squared x, we're just gonna put x squared, and we're gonna just factor like we know how to do. So 6x squared plus x minus 1 equals 0. Then you're gonna go ahead and factor this. And you should get 3x minus 1 times 2x plus 1 is equal to 0. You set both of these factors equal to 0 to solve for x, as you know. You get x is equal to 1/3, or x is equal to -1/2. This means that your sine x is equal to 1/3, or your sine x is equal to -1/2. You think of all the places where your sine has a value of 1/3, that is not on the unit circle. And because that's not on the unit circle, you're going to have to use your arc sign in order to get rid of the sine value. Now, -1/2 is on the unit circle, so you're going to have an easier time with that one. So go ahead and try that one on your own. Okay. I did the sine x equal to -1/2 first because that was easiest. I said, okay, well that's 7 pi over 6 and 11 pi over 6 for sure. And those are on the unit circle, and those fit the interval. They're not greater than pi or less than -pi. And then I say, okay, well, if I go forward, if I start adding pi's, I'm going to go past the interval, so I can't do that. So I'm going to subtract a pi, and I get -5 pi over 6. If I subtract another pi, I'm going to go past the interval, so I can't keep going. So that's how I got those first 3. Does everybody agree or have questions on this? Okay, the next one, you had to use the arc sign because there is no place on the unit circle where your sine is going to give you a value of 1/3. So you're going to have to do inverse to get rid of the sine component. When you do that, you get 0.340. Now that's one of your answers. It makes sense. It's within the interval. However, you may have another answer, and we actually did this before in, I think, 4 or 5 notes back. You say to yourself, okay, I know I'm from negative pi to pi, and pi's over here, right? And if that sign value yields a positive answer, that means that it's somewhere here in quadrant 1, right? And if you look at all students take calc, sign is also positive here. And we can get another value in quadrant 2. We just need to find out what value that is. Well, just like before with your unit circle, any of these values, you're going to go ahead and take pi minus. So you're going to do pi minus 0.340 to get your last value, okay? So pi minus 0.340 to get 2.79. And again, that's because you know there has to be another value in quadrant 2. And that value in quadrant 2, which is going to be less than pi, is going to fit in that interval that goes between negative pi and pi. You can also double check with something like this where you have to use the calculator and you get a calculator on the exam. Just graph it within that interval and you should see that you have 5 answers. Do we have any questions? No?